What we're going to do with this section is all about quadratic functions primarily. And we've looked at, certainly quadratic equations. We just haven't looked specifically at the graphing of this kind of thing and the parts of this. So here's the basic idea. You already know that's a quadratic function. Okay, you just got through solving a quadratic equation. So it had that structure ax squared plus bx plus c. Okay, this is called the vertex form. One of the things I'll show you how to do is how to change a quadratic function into the vertex form. And then hk is the vertex. That's sort of similar to circles. We've already talked about circles, how you find the center and radius, so it's kind of similar to that. And then the other thing is if this number here, this is pretty logical based on what we've known, if that's a positive number, then the parabola is going to open upward. Okay, if that number a is a negative number, then the parabola is going to open downward. So on this next problem here, I'm going to use this to show you a way to graph without having to do any calculation whatsoever. So I want to kind of start off this way. So these are in standard form. These are quadratic functions that are in standard form. You don't want to multiply it out or anything. You want to really figure out two things. First of all, we want to figure out what the vertex is. And then we want to figure out, whether it opens up or down. Those are the two key things we're going to talk about. Okay, so the vertex comes from there and there. And just think about transformations, okay? If you have x minus 2, we learned that shifts you to the right 2. Okay, what does the minus 3 do? Makes you go down 3, okay? So you can think of it that way as you've got 2 and then you've got minus 3. Okay, like that. So you're going right and then you're down like that. Okay? Does this open up or down? That depends on what's in front of the parentheses. There's a positive number there, so what does it do? Opens up. If there's a negative there, we've already learned that causes a reflection about the x-axis. So what you'd end up having with this is I want to show you how you can do this without having to do any calculations. So go ahead and start by going to 2, negative 3, and then that's where your vertex is, okay? We're going to do a couple of things on here. This is not necessarily required. Sometimes on my math lab, they want you to do what's called the axis of symmetry. And the axis of symmetry is just a vertical line that's going to go through the vertex like that, okay? Now, I want to show you this. I want to show you this on the board. A lot of times students have never learned this, and it's real helpful. So if there's nothing in front, now, if I put a number in front, it starts stretching and shrinking, but the idea is kind of like this. If you go over 1 from the vertex, then you would go up 1 to the second, because it's a squaring function. Okay, if you did this, if you went over 2 from the vertex, what you would do is you would go up 2 to the second or 4, okay? If you did this, if you go over 3, then what would you do? You would go up 3 to the second or 9. Okay, so what happens is, as long as there's no number in front of that, you can just go up 1, right 1, up 1, right 2, up 4, right 3, up 9, and so forth. Does that make sense? Because it's a squaring function, that's the reason for that. So 1 squared is 1, 2 squared is 4, 3 squared is 9, so it's just over and up the square of that amount. Okay, if you've never learned that, that's a real helpful thing to learn how to do. So this is what we're going to do then. So from the vertex, you just go over 1, then you go up 1. Okay, like that. That's guaranteed to be on there. Go back to the vertex, now go over 2, and then how high up would you go? 4, good. Over 2, and then 1, 2, 3, 4, like that. And then we'll do it one more time. Go back to the vertex and go 3 over, and then the square of 3 is 9, so you go 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you do that, you got, a series of real accurate points on your parabola. And then we have an axis of symmetry. All that means is if you reflect that over the axis of symmetry, you're going to get those same points anyway. So once you get the points on the right, then it's real easy to figure out what the points on the left are. Okay, so I'll just do that. Reflect that over, and then you've got what your quadratic function looks like that. Okay, everybody with me there? Okay, if you had like a 2, and we'll talk about this in a minute, if you had a 2 there, the only difference would be is then you would go up 1 times 2, or you would go up 4 times 2, or you would go up 9 times 2. It's just multiplying that y value by 2 if that happened, okay? So let's do one more like this. What is the vertex on this second one here? Yeah, you're going left 1. Think of that as left 1. So that's why that's -1. And what's the 4 do? It makes you go up 4. So your vertex is really being moved left 1, up 4 like that, okay? So what you'd want to go ahead and do on this one is just go ahead and plot your vertex. So you would go left 1, up 4 would be your vertex. I'll go ahead and just throw in the axis of symmetry, okay, like that. And then the negative, what's the negative going to do this time? So it's going to make it go upside down. It's going to reflect like we learned how to do. So actually what you want to do on this, since the parabola opens downward, then you're going to do this. So what you'll do is just go to the vertex, you'll go right 1, but now you're going to go down 1, like that. And then the same thing I did on the last problem. Go back to the vertex. If you go over 2, you're going to go down 1, 2, 3, 4, like that. And if you go back to the vertex, if you go over 1, 2, 3, then you would go down how much? 3 squared is 9, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Is everybody caught on to what I'm doing there? Okay, that's real helpful when you learn how to graph parabolas. That way you don't have to do any number crunching, okay? And then you can just fill in the other dots. They're symmetric about the axis of symmetry. So if that's over 3, then that'll be 1, 2, 3 like that. And then that'll give you a totally accurate graph on how that goes, okay? So that's kind of the standard form of a quadratic function. Everybody okay with what I've done there and how I'm getting those extra points? Okay, all right, it's a squaring function, that's why you do that. Okay, so the next thing I want to show you is, and we'll do this in a little bit later in the class, there's 2 ways you can find a vertex. One way to find the vertex is to complete the square. There's going to be 2 ways, and I'm going to show you both ways. You can do completing the square on a quadratic function like we did early in the semester, or you can find the vertex this way. And I'll show you both ways how to do this. It turns out if you do -b over 2a, whoops, sometimes that does that for some reason. So if you have a quadratic function which has the form ax squared plus bx plus c, if it's in standard form, if you do -b over 2a, that will always give you the x value of the vertex. And then what this is saying is just evaluate the function at -b over 2a, and that will give you the y value, okay? So you can do that both ways, and I'll show you in just a minute the 2 methodologies you can use to find the vertex. To me, it doesn't matter which way you do it. Completing the square is usually a pretty easy process to do, but the -b over 2a is always going to work. And that actually comes from the quadratic formula, okay? All right. So let's work on completing the square a little bit on the next page. And I'll kind of show you what we're going to get into here. Okay, so this is a quadratic function, and it's in a multiplied out form. What we're wanting to do, oh, it keeps doing that. What we're wanting to do is we're wanting to put this in the form a times x minus h squared plus k. Okay, that's the standard form of a quadratic function, okay? So our goal is to get that in that type of form. So what you want to do with this is you're going to complete the square. We learned how to do that a little bit earlier in the semester. So let's see what we remember on this, okay? All right, so here's what you do. Let's see if you remember that. When we completed the square, what did we do with that number in front of x? We did 2 things. What were they? Divided by 2, and then what? Then square it, right? You want to take half that number, then square it. Okay, most of the time, you can do that in your head. So I'll just kind of do that at the side. If you do -4 over 2, that's -2. Then if you square -2, you get a +4. Okay, and what you do with that is you want to take that +4 and you want to put it inside the parentheses like that. Okay, because you're going to factor that. Now, I've changed the problem. So I've got to have everything balance out on the same side of the equation. So I have a 4 there. What would you have there to make it cancel? -4. Okay, so you're working not on the same side of the equation, so you got to write that in there. Don't forget to do that so it balances out. Okay, then what you would have from here is you can go ahead and factor this, and you can do that in your head. You can go ahead and write that squared, so it's x and x. You would have 2 times 2 like that. And when you complete the square, it will always be the same factor square. It will always work that way. That's the whole purpose behind doing that anyway. So you would end up with x minus 2 squared minus 4 like that. Okay, is everybody with me what I did on the completing the square? Okay, all right. Now, look at what we have. Can you tell me what the vertex is? Yeah, 2, negative 4. Okay, think of it this way. Think of that as right 2, like we learned. So I'm going to have you write that on there. You're going right 2. And think of that as down 4. If you remember it that way, it'll help you to remember how the sign goes on this. So it would be down 4 like that. So that means the vertex is going to be right 2, down 4. So it's 2, negative 4 like that. Okay? All right, now what we're going to go ahead and do is, now that I've kind of shown you how you can graph this without having to touch your calculator, we just go ahead and sketch a graph just like we did on the previous page. So what you want to do is go over 2, down 4 to locate your vertex. Your axis of symmetry, sometimes I want you to write the equation. The equation of a vertical line is always x equals what that x value is. So you would say your axis of symmetry is x equals 2, okay? Then everything from here is identical to what I did on the previous page. From the vertex, what are you going to do? You're going to go over 1, up 1, then what? Over 2, up 4, over 3, up 9. Has everybody got that? Okay, and why? The y part is because of the squaring. So just go over 1, up 1, over 2, up 4, and then 1, 2, 3 over, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you just get the points that are symmetrical about the axis of symmetry. Okay, did I have that right? Yeah, that looks good. Okay, so I've got that. Did I miss something? No, I think I'm okay. I think my graph is just a little bit... No, that's that line's not coming out. Okay, so it should be more like that. Okay? So that's the idea, all right? So that's how you would do completing the square. Okay, I'm going to do a couple of more completing the square because there's little different nuances of the problem. They don't all work exactly the same. So I want to go through this one. This one has a negative. So just by looking at that, is that going to open up or down? Just by looking. It's going to open down, right? Okay, so we're going to go ahead and do the completing the square on this. And when you do this one, you want to do this like this. I was teaching Calculus 2 this morning, and we had to complete the square on a certain kind of a problem, so we did something exactly like this. This shows up a lot in Calculus. So what we're going to do is we're going to put together basically the first two terms. I'm just going to write that as negative x squared plus 12x, leave a little gap, and then put the minus 9 here. Now this is where you got to be a little careful when you're doing this. What you want to do is you really want to factor that negative out. You want that to be in front of the parentheses. So when you do that, you would have negative x squared, and that would cause you to change that sign on the 12x. Okay, so you got to do that when you do that. And you can go immediately to that step if you want to, so just make sure when you distribute it out, it does that correctly. Now, what's going to go here when you complete the square? 36, right? Half of 12 is 6. 6 squared is 36, right? And you're always, when you square that, you're always going to get a positive number. So what you would have here is plus 36 here. Now watch this carefully, because this is where students mess up more often than not. Okay? I got to make that plus 36 balance, so what do I put there? Okay, I got to put, but what do I put there? A plus or a minus 36? Be real careful too. Look at this. I didn't add 36. I added negative 36. See that? So that's a negative 36. So what goes there is a plus 36. You see what I mean? I see students mess up on that aspect of this problem all the time. Okay? That is a negative because that's in front of parentheses. So negative 36 plus 36. If you multiplied this all out and collected like terms, you'd be back to the beginning. So you have to do that like that. Okay, so now we factor. The negative is there. Okay, if we factor that, we would have x, and x, minus 6, minus 6. And then that would be plus 27 like that. So you would end up having negative x minus 6 to the second. Plus 27 would be your standard form. Okay, so that's a little trick that you have to apply when you have that is you have to do your completing the square like that. Okay? All right. Everybody okay with that? Okay, what are the transformations? What does this do? Minus 6, what does that do? Right 6, what does the 27 do? Up 27, right. Okay, and that kind of helps you to reason out what the vertex is. Okay, so what we have on this is transformations. We just say right 6, up 27, and it's also going to reflect. So it's going to reflect and make the parabola go, you know, open down like that. So what's the vertex? 6, 27, okay. Axis of symmetry is going to be x equals 6, because the axis of symmetry just always goes through the x value of the vertex, okay. I'm not going to do all the details of the graphing on this. I'm just going to say this, okay. So you would go over 6, up 27, okay. So we'll just kind of do that, and then we'll just kind of say, okay, it does something like that, okay. So that's the idea, all right. All right, everybody okay with the completing the square on that? Okay, there's really about 3 things that happen when you complete the square. That's how you handle it if you have a negative. The next thing gets a little bit harder for students is when you have a number in front. So you have a 5 in front of the x squared. That makes the arithmetic a little bit harder to handle on this, okay? And that's why in a minute I'll show you how to do negative b over 2a, so you could actually bypass completing the square if you don't like doing it this way, okay? So the first thing that you got to do on this, we start all these problems out the same way. You group together the things that have an x in it, leave a little gap, and then put the constant like this. But what you have to do on this problem is you have to factor the 5 out. Okay, before you complete the square, you absolutely got to bring whatever that number is out. And every now and then when you do that, you'll have fractions. This time's not too bad. So that would be x squared plus 2x. Don't do anything with the 7. That's separate from the parentheses like that. Okay? All right, now we're going to complete the square. So what would go there? A 1, right. Half of 2 is 1. 1 squared is 1. So what we would put there is we would have plus 1 here. Okay? Now, you've got to balance it out. This is the part students mess up all the time. Plus 1, what do you think? What? Negative what? 5, very good. Okay, so that's the thing you got to pay attention to. That's a 5, right? So if that's plus 5, minus 5 goes there. So you always have to pay attention to what's there. Okay? So don't fall for that. Be real careful with that. So we'll put a plus 5, minus 5 like that. So that's how that would go. Everybody okay with that? Okay? All right, then what we'd have is 5. When you factor your trinomial, you're going to have x times x, 1 times 1, 2 plus signs, and then there you'll have minus 12 like that. So we're going to write that as 5 times x plus 1 to the second minus 12. That would be the standard form, okay? And by the way, it's easy to tell you're right. I mean, it takes a little bit of work, but if you multiplied all of this out, wouldn't you just go back to the beginning? So you can tell you've done things correctly if you're ever in doubt on that. Okay, what are your transformations? Left 1. Okay, then what? Down 12. What does that 5 do? Okay, think of it this way. There's 2 things. One thing that you want to do is, you don't have to write it this way, but it's really nice to write down that you're multiplying y by 5. When you do transformations, it's good to write it that way because it'll help you understand what's going on. So if you multiply your y values by 5, they get bigger. If the y values get bigger, you're stretching, right? Okay, that's the y part of that. So what you would say is you would say that is a vertical stretch. Okay, and you have to say it's vertical. You can't just say stretch. You got to tell me which way. So it would be vertically stretching because the y values get multiplied by 5. Okay, now let me take you through. I'm not going to get all the points, but I want to get just some of the points. So it looks like for a vertex, we would have, we're going left 1, down 12. What's the axis of symmetry? X equals what? Negative 1. The axis of symmetry is just straight through the x value of the vertex. Okay, that's what that is. Okay, So let's go ahead and let's plot the vertex. We probably need to go add a couple of notches on our graph. So we'd go left 1, and then we would go down like that. So we'd go down 12 like that, okay? Now what's different on this one, so I'm not going to get all the points. I'm just going to get maybe 1 or 2, possibly 2 points. So here's what you do. Watch this real carefully. So what I kind of taught you to do before was from the vertex go over 1, up 1 squared. We're not going to do that on this problem. You're going to go over 1, and then you're going to go up 1 squared times 5. That's all that thing does is it stretches it. So instead of going up 1, you're going to go up 5. Does that make sense? Okay. And then if you had this, the other thing I showed you is go over 2, up 2 to the second. Well, we're not going to do that on this problem. We're going to go over 2, then we're going to go up 2 to the second times 5, which is 20, right? Does that make sense? That's what causes it to stretch. So if you learn it that way, you don't have to do a whole lot of arithmetic on this. So here's what we're going to do. From this point, we just want to go over 1, and then 1, 2, 3, 4, 5, like that, okay? And then I'm going to go ahead and go to the left of that like that, okay? Now, we would also do this. We would go over 2. So if you went over 2, then you would go up 20. Now, you don't have to go 1, 2, 3, 4 all the way like that. You can just reason it out. Right now, that's down negative 12. So negative 12 plus 20 is what? Is that up? That's up 8, isn't it? So, I mean, you could do arithmetic, so you don't have to count. So that thing would just go over, let's see, where's my vertex? My vertex is, what did I just do here? Did I miss my, oh, there it is. Okay, right there. So I'd go over 2. Then if I went up 20, it looks like I'd be up 8 like that. Okay? So then you would have this real skinny parabola kind of going like that. Okay? And then you would have a nice accurate graph on this one if you do that then. Okay? Okay, so I think I got that okay. All right, everybody with me in what I did there? Okay? So that's what happens with that number. Now, if that number is like a half, what if that was a half instead of a 5? What would it do? Then it makes the y's get smaller, so therefore it flattens or shrinks them. So if you understand the y of the arithmetic, then it'll help you remember that a little bit better then, okay? All right, so that's completing the square. That's 3 examples because that's really the 3 things that do happen. That one's probably the hardest one because of the factoring part on that, and that causes the stretch. So what I'm going to show you next is if you don't like completing the square, then you can go through actually and just do this formula negative b over 2a and get the vertex that way, okay? So I want to show you kind of where this comes from and show you this. So I've given you this function right here. That's a standard quadratic function. So a would be negative 1, b would be negative 2, c would be negative 5, okay, like that. So if you went through and completed the square the way I showed you, you could get the vertex that way. But actually, it's just as easy to go through and do negative b over 2a, and that will give you the x value of the vertex. So if you do that, you would have negative 2, since b is negative 2, over 2 times a is negative 1, so that's 2 over negative 2, so that's equal to negative 1. So what you would find on this is you would have negative 1 would be the x value of the vertex. Okay, everybody with me what I did there? Okay, that's part of the quadratic formula. Now, if you want to find the y value, all you do is just evaluate the function at negative 1. So take the function I gave you, everywhere you see an x, plug in negative 1. So you'd have negative 1 squared minus 2 times negative 1 minus 5. So that looks like negative 1 plus 2 minus 5. So let's see, that would be what? Minus 4 if you do the arithmetic on that then, okay? So what you would get is your vertex on this problem would be negative 1, negative 4. So you can do all quadratic functions that way if you prefer. Negative b over 2a crunches out the x value of the vertex. Then if you plug that in and find y, then you've got your vertex. Everybody follow that okay? Okay. And negative b over 2a is pretty easy to remember because it comes from the quadratic formula. Okay. So the next question I have on this is when you have a vertex, you're either going to open up or you're going to open down. Okay, in this case, that would be a local minimum like we talked. In this case, that would be a local max. So on the problem we just did, is the vertex going to be a min or is it going to be a max? It's going to be a max because it's turning upside down. You don't have to do any calculation on this. It's just knowledge of that's what's happening on the problem. So that would be a max, and it's basically because the parabola has gone upside down because of the negative. Okay, everybody with me there? Okay, so you got, those are the two ways to do the vertex. I want to go through and we'll do a couple of more things here. I want to do one more of these things with the vertex using negative b over 2a. Okay, and this one we're going to do a little bit more work on. Okay, so this time instead of completing the square, well, let's just go through and let's do negative b over 2a to find the vertex. And once you find the vertex, then you should be able to graph this and figure out the rest of it when you do that. Okay, so let's see. In this problem, a is 1, b is 12. You don't need c. It doesn't make any difference. So that c would be 0. So let's go ahead and let's do negative b over 2a and get that calculated out. So we would have negative 12 over 2 times 1. So that looks like negative 12 over 2. So that means the x value of the vertex is going to be negative 6. Okay? All right, what do you do with the negative 6? Plug it into the function to find the y value. So the next thing you do is you do f of negative 6 to evaluate the function. So you're going to go back to the function. You don't need to complete the square. You would have negative 6 squared plus 12 times negative 6. So let's see, that's what, 36 minus 72. So that's negative 36 like that. Okay, so it looks like the vertex on this one would be the point negative 6 and negative 36 like that. Okay, all right. What's the axis of symmetry? Okay, x equals negative 6. Okay, well, I'm not going to do the whole graph on this. I probably should have just given a note, not even labeled the axis, but we can at least do that and just kind of estimate what it looks like. Okay, is this one opening up or down just by looking at it? It's opening up. That's a positive in front of x squared. So we know it's going to open up. Okay, so let's just kind of do like a real rough graph on this. So we're going left 6, just put a dot there and label it. Okay, that's good enough. Okay, you'd probably, if you were doing a graph on this, it'd be wise to like go 5, 10, 15, 20 or something like that. Okay, and then what's going to happen on this one is we're just going to do a rough graph on this. We don't have to get any accurate points, but just to figure out the rest of the stuff. Okay, so how would this thing increase? What would be the interval of increasing? Negative 6 to infinity. Remember, those are always open intervals. How about decreasing? Negative infinity to negative 6. Okay, so you're always on a parabola. You're going to have one interval increases and the other one decreases. So you would say increases from negative 6 to infinity and decreases from negative infinity to negative 6. Okay, yeah, go ahead.
Wouldn't it be a closed interval because it includes 6?
Whenever you're doing increasing and decreasing, those are always open intervals. And the reason for that is, you actually learned this a little bit in a calculus class, but you have like a slope there being positive numbers. Increasing really means the slope of what we call the tangent line is positive, and right there the slope of that line there is 0. So that is sort of neutral. Okay, so basically you're always on increasing and decreasing. That point right there is sort of a place where it changes from one to the other, so you do not include that in. Now that's just because that's how, when you name intervals, increasing and decreasing are always open. So don't include them ever on increase, decrease. Okay, because that's where it changes. Okay, you'll learn a lot more about that in a calculus class, how it relates to tangent lines. So that's the idea. Just use open intervals on them. Okay, let's see. What is this, a min or a max? It's a min. Okay, so we just say, and you can just say the minimum is negative 6, negative 36. It doesn't have a relative maximum, just has a minimum. Okay, now let's go through and let's crunch out the intercepts. That's the other thing I want you to be able to do here. So I'm going to just do this at the side here. So we're going to do an X intercept, and then we're going to do a Y-intercept. Now remember, an X intercept has the structure something comma 0. So what do you do to find an x-intercept? Good, you put 0 in for y, right? So that means if you take your function, which is f of x equals x squared plus 12x, you want to replace f of x with 0. Okay, because remember, an x-intercept is something comma 0, the y value 0. So you would solve this equation. How do you solve this equation? Factor. You're going to factor. Okay, that's a quadratic equation that's factorable. So you would take an x out. So you'd have x parentheses x plus 12. So the two solutions of that are x equals 0 and x equals negative 12. So you write your intercepts as points. You would write the first one as 0, 0. And then the second one would be negative 12, 0. Okay, remember on x-intercepts, y is 0, you find the corresponding x, okay? Right? On a y-intercept, y-intercepts are always 0, comma something. So how do you find a y-intercept? You set x equal to 0. Okay, so you just do this. Okay, so if we do that, you go back to the function, and what you're doing is you're really doing f of 0. So you just see where you have x is 0. Plug that in, you would end up having 0 plus 0, so you would get a y-intercept of 0. Now, we already have that there, so you'd end up having that point like that, okay? So anytime you're doing an x-intercept, you're finding what x causes y to be 0. And that's backwards on a y-intercept. You're figuring out what y causes the x to be 0, okay? Now, if you did this, then what your graph would look like is you would end up having an x-intercept there. You would have another one over here at negative 12, 0. And then by doing that, say if you do that, then you got a really nice accurate graph by doing that, okay? So that's the idea. So that would be kind of how you do the problem without the completing the square approach, is by doing negative b over 2a. Is everybody with me there okay? Okay. I don't really care which way you do that. There's benefits to doing it both ways, but most of the time, it's a little bit easier to use negative b over 2a, okay? All right, let's go ahead and let's do our 10-minute break right now. And we come back and let's go ahead and start with this next thing right here. Okay, so let's go ahead and let's start by crunching out the vertex. By this time, again, doing the negative b over 2a. Okay, so it looks like b is going to be negative 6, so you'll have negative 6 over 2 times a. A this time is negative 1, so that looks like 6 over negative 2. So your vertex, your x value is going to be negative 3, okay? Now what we want to do is go ahead and let's plug that in. We're going to evaluate the function at negative 3, and then that'll crunch out the y value of the vertex. So that's negative 3 squared minus 6 times negative 3, and then minus 5 like that. Okay, be kind of careful how you handle these negatives too. That would be negative 9, and then plus 18, minus 5, so that looks like that's 9 minus 5, so that looks like that is 4 like that. Okay, so that's the simplest way usually to find the vertexes like that. Okay, what's the axis of symmetry? X equals negative 3. Okay, remember, that's always x equals a value like that. Okay, all right, now what we want to do on this one, we're going to try to do, since once you find the vertex, then you can actually do the graphing yourself. You don't have to do anything else. That's one of the things I'm wanting you to try to learn how to do. So let's go ahead and let's go left 3, up 4. That'll give us our vertex, and I'm just going to go ahead and do the axis of symmetry, which is x is negative 3. Okay, is this one going to open up or down just by looking? Goes down because of the negative x squared. That causes the reflection. Is there any stretching or shrinking? Is there any, what's in front of x squared? There isn't a number like a 2, a 3, or anything like that. So there is no stretch or shrink. So that means what you're going to do is you're going to go over 1, down 1, same kind of thing, over 2, down 4, and so forth like that. So let's just get a couple of points. Just 2 is good enough. So I'm going to go over 1, down 1, and then over 2, down 4. And then you can get those symmetrical points like that. So that's what would be a couple of, about 5 points on your parabola like that. Okay, so increasing is going to go from where to where? Okay, that'll be negative infinity until you get to negative 3. Again, it's an open interval. Decreasing is going to be from negative 3 to infinity like that. Okay, it does have a maximum. The maximum would be the vertex, so that's negative 3, 4, but it does not have a minimum. So that's how that goes. Okay, now we already got our x-intercepts by counting. Okay, so I want to just do one other thing on this. When we do the x-intercept, even though we already got them, what we do is we set y equal to 0. So let's go ahead and do our x-intercept. So we would just have 0 equals negative x squared minus 6x minus 5. And you would want to solve that equation just by factoring. The best thing to do in this case to me is just divide everything by negative. You can multiply both sides of an equation by negative 1, and it makes the factoring easier. To me, it's always easier to factor if there's nothing in front of x squared. So I'm going to do this. You don't have to do this, but I'd recommend it. Is really if you just multiply both sides by negative 1, then you would end up having this equation. You would have 0 equals x squared plus 6x plus 5, and then the factoring's a little easier. You see what I'm doing there? Okay. Just when you have that negative in front of x squared, you have more things to think about with factoring, so you can always do that. And then this would factor as x plus 5, x plus 1, so that means your intercepts are going to be negative 5 and negative 1. Now, if you look at the graph we already did, you can already tell that we're crossing the x-axis at negative 5 and negative 1. So I'm just going to write those as points, negative 5, 0, and negative 1, 0 like that. Okay? Now the y-axis, the y-intercept, one of the things I want you to be able to do on that is to just immediately tell what it is, okay, in your head, seriously. Because what you do on a y-intercept is you just set x equal to 0, so you can do this in your head. Okay, so if you set x equal to 0, what are you going to be left with? Minus 5, right? So anytime you have this in a multiplied out form, that right there is your y-intercept. Okay, that's the way it's going to work out if you have this in that form. So your y-intercept would just be the point 0, negative 5. Okay, so we have that. And you could go ahead and plot that point. If you go down 5, you'd have a point there, and then now you've got a very accurate graph like that. That's the idea. Okay, so that's how you would handle that without completing the squares. Everybody okay with how I'm doing that? Okay, and you can do all of the problems that way if you want to. It doesn't make any difference to me, but it is good to know both techniques. Okay, all right, let's see. With this one, we're not going to do graphing on this. I just want to quickly do the vertex and then just think about it's a max or a min, because a lot of this stuff you want to just spot. Okay, does that parabola have a max or a min? Just by looking, which is it? It's a min. How do you know? Because it's opening up. Okay, how do you know it's opening up? Because the number in front of x squared is positive, right? So that means that you're going to have a minimum like that. Okay, when we do the vertex, we're just going to do negative b over 2a. So this time b is going to be 5. A is also going to be 5. So that would be negative 5 over 10. So that would reduce down to negative 1/2. Okay, so we have that. And then if you want to find the y value of the vertex, then all you need to do is just evaluate the function at negative 1/2. So let's do that. Let's deal with the fractions. So you have 5 times negative 1/2 squared plus 5 times negative 1/2 like that. Okay. If you square out the negative 1/2, negative 1/2 times negative 1/2 is going to give 1/4. And then if you put the 5 over 1 and multiply that straight across, that's 5 over 2 like that. Okay? Don't use decimals or anything. If you got fractions, just plug in and deal with the fraction arithmetic. So that's 5/4 minus 5/2. You got to get a common denominator, which is 4. So I'm going to multiply that by 2 over 2. So I'm going to get 5/4 minus 10/4. So that will give negative 5/4 like that. So that means the other part of your vertex, the y value, is negative 5/4 like that. I wanted to do that just because I wanted to do one that had a fraction in it. Okay? So that's how you can tell if there's a min or max, and then that should establish the vertex. Okay? Okay, now the next one, these are things that I want these to just be kind of automatic on. Okay? That's in the standard form. What is the vertex on this one, just by looking? -5, 9. Because what does this do? Left 5, up 9. Okay? So if it's in the standard form, then the vertex is real easy to do. Okay? So that's why you want to know both forms of this. How about this one? Yeah, you would have to move that 4 to the other side, because this is not in standard form, but if you just subtract the 4 from both sides, now you've got that in standard form. So the vertex on this one is just going to be left 2, down 4 like that. Okay, so you want to know that kind of stuff automatically when you see standard form. Okay. Okay, other thing I want to do on this is just be able to write an equation on just some real basic ones right here. So we've got a graph. What we want to do on this is we want to write the equation. So really all you got to do is these things. You got to figure out what the vertex is just by looking. So on this one, your vertex, if I'm seeing correctly, is 2, -2. Does that look right? Okay. So what we would do on that then, it's opening up. And the other thing is you want to make sure that there's no stretch or shrink. So what I would say, remember on the vertex, if you go over up 1, then that means there's no stretch or shrink. Or if you go over 1, 2, 1, 2, 3, 4, see how those points are there? That means there's no stretch or shrink. You can figure that out by doing the counting on this. So I don't think any of these problems right here have any stretching or shrinking on that, so you just do that. Okay, so your standard form is f of x equals a x minus h squared plus k. That's your standard form of your vertex. So you plug in the 2, you plug in the -2 like that. Okay, and if there's no stretch or shrink, then a is 1, right? Okay, so what you'd end up having is your answer on this one, you'd have f of x is just equal to x minus 2 squared and then minus 2. Okay, and then that will give the equation of that function then like that. All right, everybody with me there? Okay, next one's about the same. This one you've got a vertex. On that one it looks like the vertex is 0, -1. It's opening up. Is there a stretch shrink? No, remember you're going over 1, up 1. So there's no stretch shrink on that. That's standard. So that means your answer on this would be f of x. You can say x minus 0 squared and then minus 1. Now you can write it that way, or you're just as well to even write it that way if you want to, x squared minus 1 like that. That's the idea, okay? Okay, and then the next one, let's see, the vertex on this one is going to end up being, again, that one is 0, -1. This time it's opening down. There is no stretch or shrink. So you'd have f of x, your standard form is a, x minus h squared plus k. Okay, what are you going to put in for the a this time? It's a -1, right? Okay, it is going down, so you put the negative. You don't have to put the -1, so you just do that. X minus 0 squared, and then minus 1 like that. So the simplest way to write this one is just -x squared minus 1 equals f of x. Okay, so a lot of times in math you like to do things forward and backwards. If you can do a graph, then you want to be able to take a graph and write a function. Okay, and I'm not going to focus on the ones that have stretch and shrink. There's other ways that you can do that. I'm just kind of looking at the standard ones there. Okay, all right, we've talked about this, so I want to kind of finish up a summary here, and then we'll go through some of the applications that you're going to need to know how to use your calculator on. Okay, how do you find a y-intercept? What have we always been doing? Plug in x equals 0. The other variable goes to 0. So if you find a y-intercept, let x equal 0. Now you want to be able to do this in your head. What's the, well, hold on, I'm saying that backwards. Y-intercept you want to do in your head. Okay, most of the time you got to do something on these. So you would just say x squared plus 5x minus 6 is equal to 0. And then you would try to solve that by factoring. If it doesn't factor, hold on, that says y-intercept, doesn't it? Now I've got myself confused. Okay, you set x equal to 0, so what's the answer? There we go, I confused myself. Okay, so yeah, you just do f of 0. So you have 0 squared plus 5 times 0 minus 6. So the y-intercept is just -6. Okay, so you'd end up writing that as a point like that. Okay, same thing on this one. So what you would have to do on this one, if you want to find the X-intercept or the Y-intercept when you're in this form, is just let the X be 0. So on this one, it looks like you'd have 0 plus 3 squared minus 9. So that's 9 minus 9. So that's equal to 0. Okay, so that means your point on that is going to be 0, 0. Okay, so basically Y-intercepts, and notice this one, that one is automatic. That's your Y-intercept right there if it's multiplied out. But if it's in the standard form, a lot of times you have to do a little bit of arithmetic computation on that then. Okay, all right, let's look at this. I want to just look at something a little bit different with what we're doing on 16 and 17 is we're going to look at what the domain and what the range is. Now, we don't want to graph or anything. We just want to understand what it is, okay? Just sort of reason this out in your head. So what's going to happen on this one is you have a vertex of 1, negative 14, and you're opening up, okay? That's all you got to know. What's the domain? That's everything, okay? If you have a parabola, everything is always the domain. At quadratic functions, the domain's always all real numbers, okay? So if it's opening up, what's the range? Negative 14 to infinity. Do you include the negative 14?
No.
Yeah, that's why I asked, because I was going to see what you said, yes or no. Okay, yes you do, because range is different than increasing and decreasing. What you're doing is you're saying, okay, that is a definite point on there, and then beyond. They're two different things, okay? That's why I was asking, okay? Testing you out over there. So that would be negative 14 infinity is how that goes, okay? All right, let's see. This one says you have a maximum is negative 8. I'm not even sure what I did on this one, if I left something off of that or something.
It's supposed to say equals 1.
What's that?
R says equals 1. And X equals
Oh,
1.
that's why I'm confused. X equals 1. Oh, it didn't import. Sometimes these things don't import into OneNote. Okay. All right, so here's kind of the idea. Well, what this is it's just saying, okay, when X is 1, Y is negative 8, that's just saying that's a vertex on there then. And that's saying that's a maximum. So what does the parabola have to do if it's a maximum? It has to go down. And that's really all you got to look at on that is you have a vertex like that. Okay, the domain is always all real numbers on a quadratic function. So what's the range if it's opening downward? Negative infinity to negative 8, right? Okay, so you'd say negative infinity and then negative 8 with the bracket like that. Okay, now there's a lot of problems on your homework that are just things you do kind of quickly in your head, kind of drilling on some of that. The only things you really got to work out much on this section are when you do the graphing and completing the square and finding the vertex. That's where the work is. But things like this you want to be able to just kind of quickly do in your head. Okay? All right, now we want to get your calculator out because the rest of these problems you have to do in this class with your calculator on. Okay? So I'm going to do about 4 examples. Some of these are pretty similar to what we did last week in one of the sections. So basically what's going on this problem is this is a projectile. If you study physics, you're going to see that when you throw an object on the Earth, it always travels in a parabolic path represented by a quadratic function. So you can find maxes and mins with your calculator, and then when you get to calculus, you can do that more with calculus methods. So what this one is saying is it's saying how far from the base of the cliff is the, what does it say over there, is the height of the projectile a maximum, okay? So we want to go ahead and we want to put this one in our calculator. So let me get my calculator put together here. And just do this with me if you brought your calculator. If not, you might want to write down the keystrokes if you need to. So the first thing you want to do is we want to put this in. Now, I went ahead and wrote on here the way to put this in. So on Y1, I'm just going to have you put in parentheses, negative 32, and then x to the second, and then divided by, and then you can just do 210. Now you can do the 210. You don't have to have parentheses on that, but you can do that like that. You don't have to do it exactly like I typed off, because all that you need the calculator to do is just do 210, square it, and then divide those. So a good rule of thumb is when you have a fraction, have the numerator in parentheses and the denominator in parentheses. A lot of times students don't do that correctly. Okay, then we just put in the plus x, and then we'll put in the plus 100 like that, okay? And what we're going to do on this, there's a couple of things that are going on. The projectile is fired from 100 feet above the water. So we need to figure out what our viewing window is. And this is what I always recommend that you do, is if you need to figure out your window, go second graph and look at your table of values. And just look at how things are going. Now this is x is time. The smallest time is 0. So notice on this problem that what's happening is you start 100 feet above the ground, the projectile goes high up, eventually it's going to start dropping down to Earth. So if you go through and scroll through this, this will give you a pretty good idea, and you can just, you know, kind of predict. Maybe we need to go up to 200 or something like that. You don't have to go all the way through, but eventually it's going to start dropping down, okay? So what I'm going to do, just based on what I did there, I'm going to start this way on my window. I'm going to start like with 0, and I have no idea, but I'm just going to take a guess and try 50, okay? I don't know when it's going to hit the ground, but let's just try something that's pretty reasonable. Okay, when I do the y's, I'm going to start at 0 because 0 is the ground. I was seeing numbers in the hundreds, so I'm just going to take an educated guess, and I'm going to say 150 maybe scaled by 10. Now, as long as we can see the whole entire graph and see where its maximum is, we're good. If we need to adjust, hey, we're going to adjust, okay? So let me put that in and let's see what happens. What do I need to do? I need to go further out on x, don't I? Okay, I didn't go out far enough on x, so I'm going to adjust. So let's try to make that go, let's try to do something like, let's go further than 100. Let's go maybe to 200, like that, maybe scale by 50 or something like that. And let's try again, and then maybe make the y's go up a little higher. I'm going to make that go up maybe to 250 or something like that. Okay, so you can play with that a little bit. I'll show you how to do zoom fit in a minute, but usually I like to just sort of try to play with it a little bit. So if you look at this one, it's going up for a long time, okay? All right, let's try this, okay? If you go zoom, generally on your zoom button, if you go zoom fit, sometimes it'll give you a good picture by doing that. So you can try that if you want to. So I'm just going to do zoom fit. And let's see what we get. I don't know if I like that any better, but eventually we're getting a little bit better on that. So you just need to keep adjusting it until you get to where you want to be. Okay, I don't think zoom fit did much on that. Okay, I'm going to be bold. I'm going to go all the way up to 1,000 and then see. So I'm going to try that, and then I'm going to try for my Y min. I'm going to go 0, and let's go up to 1,000 there. I'm just going to try some big numbers and just kind of play with it and see what I end up getting. Okay, I'm going to try that. Let's see what happens. Finally, okay, see what I mean? So I just sort of play with it until I find what I want to find, okay? All right, so I'll put this window up here, and you can put in that viewing window if you want to do that. Then I'll show you how to finish this up, okay? So the rest of this, and I'm not going to have you draw a graph on this. I want you to just put that window in and get that, and then we're going to go through and find the maximum like this. And we've done this before, so if you need to go through and write the keystrokes down, what you end up doing to find the maximum is you do second trace, like that. Write that down if you need to. Some students have never learned how to do, some people have. Then when you go to second trace, you will go to option 4, which is finding the maximum, and then you press enter. Okay, so we want to just press enter. Okay, get a left bound. Left bound just means be to the left of where that is. That's good enough for how mine popped up. Right bound, use your right cursor key, and make sure that you're a little bit to the right of where that maximum is. And usually the more modern calculators put lines. Some of the older ones put triangles to establish the bounds like that. Okay, so I think I'm convinced I'm good. Now when it says guess, just press enter, and then it should tell you what that max is. Okay, so when you get that, it looks like the calculator is going to give 689.1. I'll just round to 1 decimal, and then 444.5. What that would actually be is that's your vertex of your quadratic function. Okay, everybody follow what I'm doing there? Okay. The thing that you have to play with a little bit on some of these problems is the window. So it took me a few times to come up with numbers that worked, and you have to do that. You can also try zoom fit, but that doesn't always work real well. Okay, so what this would say then is it says how far from the base of the cliff will the projectile be at a maximum? So that the answer is not the point. The answer is this right there. That's how far away you are. That right there is the height, and then this would be the distance from the building. Okay, so the answer to that problem is actually this. Okay, does that make sense? Okay, so you've got your height, but that would be the distance from where the projectile started. Okay, everybody fine with what I did there? Okay, all right, so we're going to do a few more examples where you have to use your calculator on these graphs. And everything in this section has to do with quadratic functions, okay? So this one we haven't done yet, but we've done a few things similar. And these are pre-calculus problems. These are things you will revisit in a Calc 1 class. So this problem says you have 300 feet of fencing and you're enclosing a rectangular area. You're going to find the dimensions that maximize the enclosed area. So you got to set up a function that you're going to graph on your calculator. To start with, what I would do is I'd just draw a picture of a rectangle. And you want to label kind of what you have on this. So you don't know what the dimensions are. Your job is to find the dimensions. I'm just going to call those sides X and those sides Y like that. Okay? So if there's 300 feet of fencing, what would be an equation that would relate that 300 to my sides? 2x plus 2y equals 300, because you're doing the perimeter, right? If you have a total of 300 feet of fencing, then you're going to end up having the perimeter, which is 2x plus 2y is equal to 300. So that's how you want to start the problem, is by getting an equation that represents really that first sentence. Okay? Step 2. Okay, what does it say we're doing? We're finding the dimensions that maximize the area. So whatever you're maximizing is what you're going to graph. Okay? So how do you find the area of this rectangle? X times y, exactly. Okay, base times height. Okay, and that's what you want to graph. However, and we've already talked about this last week, how many variables does this need to have? Just one. So what you need to do is take this equation, solve for probably y, it doesn't really matter, and then plug into there. Then we have to go to our graphing calculator, see. Okay, so the idea with this is we're going to go ahead and take this equation. That would be 2y equals 300 minus 2x, divide by 2. So that's y is equal to 150 minus x. And see, this thing right here, you want to plug that in. Since that's y, you want to plug that in for y right there. Okay? So what you would end up having is you would end up having the function a is equal to x times 150 minus x like that. Okay? And if you multiply that out, you would just have 150x minus x squared. Okay, and that is a quadratic function, right? That's a parabola opening downward, correct? So what we're going to do is we're going to put that in our graphing calculator to figure out the problem. Okay, is everybody okay with what I did so far? Okay, so the rest of this at this level of a class you got to do on your calculator. So I'm going to put in, erase what I had before, and I'll just put in the 150x minus x squared, like that. And if I graph that from the same window, there's no telling what will come out. Well, okay, that gives me some sort of an idea. I got a parabola that's going to go way up there, like that. So what I'm going to do for a window, and again, you got to play with this a little bit. I'm going to try something like maybe 0 to a 200 or something like that. Okay, and then maybe scale by 100. The y's are going to be really big on this. So I'm going to try something like 10,000 to start with. I'm just kind of taking a little guess on this one. And you don't have to put this in yet. I'm just going to kind of see where I am. Okay, that's pretty good. Okay, so I'll slide the window over here so you can put in this window. and then you should get the same graph I get there. So then it's all the same. So what you're doing on this is you're finding the dimensions that maximize. So what you do is exactly the same thing. You could find that vertex. Now this vertex could be found by doing negative b over 2a also, but I want you to do this one with your technology. So I'm going to go second trace, option 4, and then just get the vertex that way. Okay, and this calculator is a little slow sometimes. Let's see. Right bound. And if you mess up on the left bound or right bound, it will give you some sort of an error. So it looks like that vertex is going to end up being 75 and then 56, 25 like that. Okay, so that's what you end up getting. Okay. All right. Now what we want to do with this is we want to find the dimensions that maximize this. Okay, so what you have on this is what x is. Okay, so your dimensions, you would have x is equal to 75. So in my rectangle, x would be 75 and 75. Well, how do you find y? Well, here's the easiest way. You can either go back to that equation, or you can go there. That's the easiest way. Y is 150 minus x. So what you could do to find y on this is you could just do y is equal to 150 minus 75. So it's also 75. So what you would end up having is a square. And that's what happens in a rectangle. If you're trying to maximize the area, you have to condense it into a square. Because the other choices would be to stretch it out long and skinny or shrink it so it's real tall like that. But that's the way to maximize is a square. Is that logical to you? Okay, all right. So you would have 75 by 75 would be your dimensions then. Okay, all right. Is everybody okay with what I did there? Okay, the key thing is getting your function set up in one variable, then you got to turn over to your graphing calculator. Okay, the next problem I'm going to do is slightly different. It's very, very similar, but it's got one little twist to it. So let's run through that one now. Okay, and I want to just wrap up with these two things here. So this one's a little different. This is another one you'll look at probably in a calculus class. So what you have is you have 120 feet of fence, and then this time it's enclosing a rectangular plot, but it's bordering a river. Okay, so I'm going to draw my river. Okay, there's my river. And what you're going to have is you're going to have really 3 pieces of fence that are going to go more like this. So I'm going to have one piece of fence there. Why is it not doing my color? Just draw your rectangle around like that. Okay, so we'll have that, and then we'll have that. And then again, you label this however you want to. I'm going to call that X and Y. And you can do that backwards. That's totally up to you. Okay, so we want to get 2 equations. The first equation, how does X and Y relate to 120 in this problem? It's different than the last problem. What is it now? It's X plus Y equals 120, because there's only 3 sides, because we're not counting the river. So what you would end up having for your equation is 2x plus y is equal to 120. Okay, so that's what you have. Okay, then you're still going to maximize the area. So the rest of this problem is very similar. The area in this would be what? It'd be xy again. Okay, it's no different. And then again, you want to have that in terms of one variable. So you can solve this however you want to. What I'm going to do is just solve this for y. So I'd have y equals 120 minus 2x. Okay? And then this thing, what y is going to plug into your other equation, see. So you want to just take this and plug it in. Okay, like that. And then we'll go to our calculator to finish this up. So that's going to be area equals x times 120 minus 2x. You can multiply that out. You would have the quadratic function, 120x minus 2x squared like that. All right, does everybody see the slight difference in that problem? So the last one turned out to be a square. This one's going to turn out to be a little bit different. So let's put this in our graphing calculator, and we just repeat the same thing we did on the last problem. So I'm going to clear off that, and we'll put in 120 times x minus 2x squared. And I'm going to try the same window and see if it gives me a picture. All I got to see is a parabola opening down. That's good enough, okay? right? It doesn't have to be perfect. So we're going to go ahead and do the maximum on that. And option 4 again. And then you want to do your left and right bound on this, okay? Gotta find my cursor, come on. There it goes. Okay, so that's a good left bound. We're going to get a good right bound. And then we'll just write down the vertex on that. Okay, so this is what's coming out on the problem. And it looks like you have a parabola opening downward, and it looks like you have 30 and 1800. Is that right? Sometimes I can't see this little print on this, and I can't zoom in on that calculator right. Okay, so that's what you end up getting is x is 30. So we got that. That would be the first dimension you would get. So we want to use 30 feet of fence there, and then 30 feet of fence there, and then we got to find y. Well, the easiest place to find y is 120 minus 2x. So if you just do y equals 120 minus 2 times 30, let's see, that'll give 120 minus 60. So that will give y is equal to 60. So what you end up having on this is you have these dimensions. You have 30 feet that way and 60 feet that way, okay? And if you were wanting to find the area, well, the area is just 60 times 30, so it's 1,800 square feet. So it wasn't a square this time. That's because we had that missing part like this. So this one, the answer is just 30 by 60 feet. All right, does that make sense to everybody? Okay, those are kind of basic calculus optimization problems. So that would be the idea between those two there. I assigned some of the more basic ones on your homework like this. The ones you'll see are pretty similar to this. Okay, this problem I want to do one more. This one is, again, a projectile, but you're not finding the maximum height on this one. We're going to graph this on the calculator, but then the question is, how many seconds does it take before it hits the ground? So you have to take a little bit different approach on this problem. And we're going to do this one with a graphing calculator, but you could also do it without, and I'll explain that in just a minute. So let's go ahead and put in the function. So we have a quadratic function, so it's negative 16, and then we'll have to put in x squared plus 112 times x plus 80. And what the window is, I don't know. I'm going to keep the same window from the same problem. I know I'm looking for an upside down parabola. I saw a little blip coming out, so I'm going to do this. I'm going to do like something like 0 maybe to 20 or something like that. And let's see, the y, let's just try like 100 or something like that. As long as I get a good picture, we're okay. So I'm going to go ahead and try that window, and then if that works, I'll show you what it is. I don't like that. I need to make it a little higher. So let's take that maybe up to 500. Okay, that looks like a good one to me. Okay, so if you didn't get the window, you can put that in like that if you want to. And then we'll go ahead and we'll find the vertex like we've been doing. Okay, and then after I do this, I do want to talk a little bit about what you're doing on this. Now, I do need to adjust the window a little bit differently because we're not finding the maximum. We're finding when it reaches the ground. Well, it reaches the ground when the height is 0, right? Okay, so you actually have to find that X intercept right there. Now let me show you how you do this on your graphing calculator. It's a little bit different. So if you haven't done this before, you might want to write out the keystrokes. So if you want to find an X intercept, which is what we have to find, then you go second trace. You open this up the same way. Second trace. And then you'll have option 2 will be what's called a 0. So you got to go down to 2, and then you got to press enter. Okay. Then I'll show you kind of how this works on this. So you'd have to press enter, and then you do the same thing. You do a left and you do a right bound. So on this one, let's see, the cursor should pop up here in a minute. You want to get a left bound. So the left bound is just going to be a little bit to the left of where that is. And then the right bound, you just got to use your right cursor key until you're to the right of it. I don't have that great of a window on it, but I could start like that. And then for the right bound, hey, as long as I'm out of range, I should be okay. So I do that. Okay, that gives me a left and right bound. Then it says guess, I press enter. And it'll blink on there. You're always going to know you've done that right because it says y is 0. So that right there would be the X-intercept if you do that. So you have to use the 0 command on that. So that would end up giving you what looks like about I'm going to say 7.65 and 0 like that. Okay, so what you end up having, and you don't need to draw a graph on this unless you want to, but the key thing that I want to show you on this is, come on, get over there, is that the X-intercept is what you're finding. So with this one, you've got that point. Okay, so what's the answer? The question was, how long does it take for it to reach the ground? Yeah, 7.65 seconds. That's your answer right there. The 0 just means you have a height of 0, so therefore you're on the ground. So the answer to that problem would just be 7.65 seconds then. That's it. Okay? What's that? Oh, did they say round to the 10th? Yeah, I'm not even paying attention. So that would be what, 7.7? Okay, so 7.7 seconds. Okay, everybody follow how I did that and what the difference is on that? Okay, now I want to do one more thing before I let you go because I do want to show you this problem in a slightly different way. I want you to have a little bit of a balance between being able to do stuff on your calculator and without a calculator. So I've shown you kind of how to do this. So if you were doing this without a calculator, let's kind of talk about what we would do. So you have this function. So you would be finding an X-intercept, right? So how do you find an X-intercept? You set the function equal to 0, right? You set y equal to 0. So you could do that. Now let's go ahead and let's do this. And I'm not going to finish the problem this way, but I want to just kind of talk through what you would do. One thing that you could do on that is a quadratic function, and it does not factor. I know it doesn't factor because of the weird answer I got. So what you would end up having to do with this one then is you would end up having to just go to the quadratic formula and put this in. I'm not going to work all the details of that out, but if you did, you would end up having negative 112, negative b, plus or minus square root of b squared, and then 4ac, so a is negative 16, then c is 80, and then you would do all over 2a. Now, if you did that on your calculator, which you would have to do, you should also get the same answer, 7.65, okay? So sometimes on these problems, they're easy to do if that factors. So if that thing factors, it's just as easy to set it equal to 0 and solve that way. Otherwise, you want to make sure you know how to do the technology and then apply the formula if you have to, okay? So that should give you the kind of pre-calculus applications that I want you to know how to do is working with functions and your calculator to find if something's a max or min. Okay, is everybody okay with that? Okay, all right, so I'll finish this up for tonight, and then next time we'll do 2-3, and then I'll bring 2-4, and I'll be bringing a test review next time too, because your test is next Thursday that covers up to 2.4. Okay, if you need any help with the assignment that's due today,